Scenarios that can happen with Cauchy-Euler equations. So there's two other possibilities. One is that, here we had distinct real roots. You can have repeated roots. So let's look at something like, if we were to look at where we were to have repeated roots, let's look at something like x squared y double prime plus xy prime equals 0. And if y is x to the m, then we know that y prime is m x to the m minus 1. Y double prime is m times m minus 1, x to the m minus 2. Plug everything back in, and we get m. So let's call our differential equation star. So our differential equation is going to be m times m minus 1, x to the m minus 2 times x squared plus x times y prime, which was m x to the m minus 1. That's going to be equal to 0. And again, the x to the m terms we can just get rid of, and we're going to be looking at m times m minus 1 plus m is going to be equal to 0. And so that turns out that we're going to have m squared equals 0, and here we have m equals 0 as a solution of multiplicity 2. So we already know that one of the solutions is going to be c1 x to the 0, or just c1. It turns out if you want to find the second equation, what you need to do is that reduction of order technique that we talked about when we had repeated roots for constant coefficient second order equations. And it turns out that when you do this, what's going to happen is you're going to end up with the same quantity that you had before times the natural log of x. So if you do that reduction of order technique, that's really just where you multiply by g of x and figure out what's the function g of x that'll work for you. It turns out that you'll have whatever your solution was times natural log of x. So in general, if you have, your solution is r of multiplicity 2, then that tells you that your general solution is going to be c1 x to the r plus c2 x to the r natural log of x. In our case, r was 0, so it's probably better just to write it as c1 plus c2 natural log of x. But that's how you deal with repeated roots for these Cauchy-Euler equations.